Alright guys, this video we're going to take a look at balancing chemical equations. We're going to do this just by sight. There are a lot of methods that you can use to do some scratch work, but in my experience it's just as easy to learn to look at it and figure out how to solve them. A couple of keys to success. First, you have to realize that you can never change the subscript on an equation. For example, in the first one here I have O2. I can't make this O2 on this side. That's not an option. Whatever we have is what we have to stick with. The only thing I can do anywhere is to put a number in front of a compound, and that will change how many atoms of each element I have. Okay. For example, here, if I put this 2 here, realize that N2O is this. This is N2O, 2 N's and an O. So if I do 2 N2Os, what I'm actually doing is doubling both. So this doesn't add. I don't get 2 plus 1 is 3. I get 2 times 1 is 2 oxygens, and 2 times 2 is 4 nitrogens. So whenever you put a coefficient in front of something, it affects both items that are in that compound. Okay. What I've done here is color-coded the elements, so it's easier to see where they are, and we can trace how the coefficients are affecting the individual parts of each compound. The goal is to make whatever I have on the left side, or the reactants, equal what I have on the product side. The left is just the reactants, the right is the products. This little sign right here means yields. It's sort of like the equal sign. We can think of it as the equal. So as long as I have the same number of atoms of, example, nitrogen on the left side as I do on the right side in this one, and oxygen on the left side as the right side, and then I'm balanced. Well, we can see right away that my nitrogens, my red ones in this problem, I do have 2 atoms of each, so I'm good there. So I'm going to turn my focus now to the oxygens. You can see that there are 2 oxygens in the reactants and only 1 in the products. So remember, I can't fix this by changing the 2 here. I have to actually put a 2 here. So that does indeed give me 2 times 1 oxygen to give me 2 oxygens, which is what I have on the other side. But one of the side effects of doing this is now I've doubled the amount of nitrogens that I have here. I have 4 nitrogens now. 2 times 2 is 4. So I need to have 4 nitrogens in the reactants also. And that's an easy fix. Since there's a 2 right here, what times that 2 will give me the 4? And that is a 2. So now 4 nitrogens, 2 oxygens. 2 times 1 is 2 oxygens. The first equation is balanced. The second equation, this looks a little more complex, but it's really not. With polyatomic ions, these things that are grouped together, if they occur on both sides of the equation, you can keep those together and consider them to be one unit. That's why I color-coded them this way. You see that I have SO4 or sulfate in the reactants here, and I also have sulfate in the products. So when I'm trying to balance this, I'll see this as 3 sulfates, not 3 sulfurs and 12 oxygens. We also have hydroxide in the reactants, and we're keeping the hydroxides together, so this is 3 hydroxides, not 3 oxygens, 3 hydrogens. So the easiest way to do these is just to start with something. I usually start with the first item there. I see that I have 2 irons in the reactants. I need to have 2 irons over here to make that equal. So my first move is to put a 2 in front of the iron. So I've done what I wanted to. I've made 2 irons to match the 2 irons over here. However, I've given myself 6 hydroxides in the products, and I only have 1 over here. So I have to come back to this side of the equal sign and make it the same. So I put a 6 there to give me 6 times hydroxide. Well, that fixed my hydroxide problem that I had just created, but now I've got 6 potassiums. So I need to make sure I make my potassiums on the other side of the equal sign match. So what times the 2 that I have in the potassium will give me the 6 that I have over there? Well, a 3 will do that. 3 times 2 is 6, and I have 6 times 1 is 6, so those are equal. But it changed my sulfates now. You see, this 3 affects everything within this one unit here. So 3 sulfates. So I need to go ahead and fix that on the other side, but lucky for us, we needed 3 anyway, so this actually solved our problem. So it's just a quick double check. Just count each item and make sure they're the same on each side. So starting with the irons, 2 of them here, 2 times 1, 2 of them here. We're good on the irons. SO4 sulfate. Well, I have 3 sulfates here. Remember, this 3 just goes and tells me I have 3 inside the parentheses. 3 times the sulfate here, that's the same. Potassium, I have 6 times 1 is 6. Here I have 3 times 2 is 6. And the last item is hydroxide. 6 times 1 hydroxide should be equal to 2 times 3, and that is 6 on both sides. So this equation is completely balanced. Turn our attention to this last one. This is the combustion of a hydrocarbon. What I like to do whenever I have an item just by itself, like this oxygen right here, this should usually be the last thing that you try to balance, okay? Because I can just put a number here in front of it and just match up whatever I need on the other side. So we focus on the oxygen last. So the first thing we see is I have 2 carbons in the reactants, 2 carbons in the products. So let's go ahead and try to make that the same. We can put a 2 there. So that fixes my carbons to be the same. Affects my oxygen, but remember, we're leaving the oxygens for last. So now I have 6 hydrogens to worry about. I have 2 hydrogens over here. So I need to make it 6. Well, 3 times 2 will equal 6. So now I've got 6 hydrogens and 6 hydrogens, 2 carbons and 2 carbons. It's time to take a look at the oxygens. If you notice, I have oxygen in 2 different places in the products. Okay, it's coming from the CO2 carbon dioxide compound and the H2O water molecule. So I need to add up both of them and have that equal the total number of oxygens over here. So right now I have 3 times 2. I have 6 oxygens right here. I'm sorry. 2 times 2 is 4 oxygens right there. And I have 3 times 1 is 3 oxygens right here. So I have a total of 7 oxygens in the product side. Well, these oxygens only come in 2s. So I can only multiply something by a 2. And this is an odd number. So what we can do here is we can still say, well, what times 2 will give me 7? Well, it's going to be a decimal this time. 3.5 times 2 will give me 7. And now I have an equation that is completely balanced. We've seen that the 2's were balanced, and we verified that the 6's were. And now I have 3.5 times 2 is 7 oxygens. That equals my 7 oxygens here. However, we cannot leave a 0.5 in the equation. So the rule is anytime you've done this when you had an odd number and you had to use a half to go ahead and make it work, you have to multiply the entire equation by 2. Because if I have a 1/2, if I multiply 1/2 times 2, it equals 1. So what we do is we just multiply everything in the equation by 2 and it fixes itself. So this right here was an understood 1. I have to multiply it by 2. This was 3.5, so I have to multiply that by 2, and the correct coefficient will be a 7. 2 times the 2 that I have there is going to be a 4, and 2 times the 3 that I had there is 6. So neaten this up, I'll just make this my final answer for this part will be the 7. This will be a 4, and this is going to be a 6. We can verify that this is balanced. 4 carbons here, 4 carbons here. 12 hydrogens here. 6 times 2 is 12 hydrogens here. And then 14 oxygens. I've got 4 times 2 is 8, plus 6 times 1 is 6, giving me 14 oxygens on both sides.